All right, we're going to jump in. I'm going to start off talking about FML Basics. So we're going to talk about what is FML, how to use it, and show some examples. Nothing really complicated. I'm saving that for Marcus. So what is FML? So in a typical report, you identify the columns you want to see on a report, and you have the sort orders. And that's pretty much basically it. You can go down with a by in your sort order, or you can go across the page using the across. You can also do free text. But in FML, it allows you to do row and column calculations, and that's the main power behind the FML. It also lets you, I want to say, put things in buckets. So if you have an account number that has, let's say, 16 digits, and the first 10 might represent a particular customer, then you can do a report showing everything starting with those first 10, and then that would all be aggregated into the same bucket. So FML lets you do free-form text. You can do inter-row. Again, inter-row calculations is the main power behind FML. So how do you do an FML report? So I'm going to show you, and don't tell many people, but I'm going to show you how to do this in App Studio. Yes, App Studio is still available. It's not going away. But eventually it will also become part of the designer tool. So that's one of the things we're looking at for in the future. So to create an FML report, financial modeling language, we are going to create a normal report, identify what column in the report is going to be the one that we're going to bucket or bucketize, if that's even a word. We're going to put all the values in that category into that bucket. You're going to specify any sorting. You can also have crosses and your full plethora of headings, footings, subsets, all that stuff. So in Report Painter in App Studio, I'm just going to jump in. We're going to start creating our report. So we're going to drag and drop the columns we want to see. So we already have dollar sales, budget sales, and product. And then I highlight, so I want to do things by product. So I want to see different products, the biscotti, coffee grinder, all that stuff. I want the values grouped up by that. So I'm going to highlight and select product. Oops, sorry, I'm jumping ahead. So this just shows you the basic report that we just generated. To make it into an FML, we're going to take the same report. We're going to collect product. Then we're going to click on the for row, because now we're going to tell it this is an FML report. And then at the bottom of the screen, you have those tabs that say report, source, images, and matrix. We're going to select matrix. And then we get this type of output. So we have rows, and then all you need to do then is drag and drop whatever value that you want to see on that row. So if I drag and drop biscotti, then I will get all the biscotti values summed up on that row. So here I dragged and dropped biscotti, croissant, and scone. Okay, let's run that. So here's the code that gets generated, some dollars, bud dollars. Notice it says for product as opposed to by, because remember we clicked on that for item once we selected product, and then we have the 3 products that we selected and dragged over. So here's my output, biscotti, croissant, scone, the values. But notice that there's only 3 values, and we have a lot more products than that in the GG sales product. So why is that? Why are there only 3 rows of output? Well, when you're doing FML reporting, if you don't specify the value in your for list, you're not going to see it. So it's an implied where condition. So you're putting the rows where you want them, but you're also doing a where filter. Okay, keep that in mind. Which means if you were to type this by hand and you misspelled something, or notice biscotti is multi-case or a mixed case, If you put it all uppercase, then you're not going to see it because it's not a direct match. What you will see is the all uppercase value, but with no values. So that brings the second part. If I have a value that I don't have, if I have an entry that I don't have a value for, it's like inserting a blank row. All right, so here I have, so this is back to a non-FML report where I have by product as opposed to for, but I have the same functionality and we call this rows over. And this is, I've spoken about this in other presentations on sorting your way. So I can say if I want to report by product, rows biscotti over croissant over scone. It works exactly the same as the FML, but it doesn't have all the power that FML has. So it's like a mini FML. So again, you only get the 3 rows that you specify, or however many rows you specify. Your different row types. So you have your tag, which identifies your values. Recap does calculations. Text is to put in just free-form text. And then bar, in the old financial reports, the income statements and balance sheets, you would total everything, have a single line, and then at the grand total, you would double line it or double bar it. Other types of rows, you have a data row and a pickup row. We don't go into those in this session because we're just talking basics. Pickup is if you were to have posted data from a previous FML and you want to then incorporate those values. So you can post them, basically it's like a hold. You're putting them into a data set and then you can pick them up in the next FML report. So here we're showing an example of bar. So we're doing a bar as a single underscore. And I'm doing it after the biscotti croissant scone. So I'm kind of breaking up into product types. So I have, looks like a food, and then we have drinks, and then we have items. So if you see the lines, we see the lines now separating the sections. In this example, I am now adding food items. So I'm putting a label on top of the individual sections. So I got food items, coffees, and gadgets. I'm also doing a recap. So recap lets you do calculations. So the recap is going to give me a total for each section. So notice on line 12, I have recap R5 equals R2 plus R3 plus R4. So if you look up further, R2, R3, and R4 are the biscotti, croissant, and scone lines. Notice I have an as that says total food method 1, because that's just one way of doing the calculation for the subtotal. I could have also used the data values as opposed to the row number. So biscotti or croissant or scone as total food method 2. So you have the option. You can either use the row alias, the tag, or you can use the actual value for that row. At the bottom, notice I highlighted this on table set for multiple on. So once you use a value in FML, you can't reuse it. So if I had biscotti and I use it one place in the food item, and I want to use it a second place, say in the recap, I can't do that because I only have the ability of putting the values in one bucket. That is, unless I say I want to set for multiple, I want to have multiple for references and turn it on, which is what this setting is doing. If you didn't know to set that yourself, you can set it in the painter. There's a use multiple values checkbox. You check it and it puts that line in for you. If I didn't check it, once I notice in the grid, I have biscotti, croissant, and scone, but on the right column list, I don't have those values because you dragged and dropped them. So once you remove it, it's gone unless you check the use multiple values, and then it will stay there to allow you to reuse it in other areas. All right, so here's our report so far. Food items, biscotti, croissant, scone, total food, the two different methods, just to show you, you do get the same values. All right, so what else can we do to this? How about we add a grand total? So I'm going to recap R20, row 5 plus row 12 plus row 19. So that gives us the overall total. And at the bottom, we see the overall total. And for those of you that are awake, there is a misspelling. All right, the last thing we're going to do is we're going to make it just a little bit prettier, because this is kind of all flat and left justified across the way. Wouldn't it be nice if I could indent the biscotti, the croissant, the scone, kind of make it a little more readable? So that's where the indent keyword comes in. So you do indent and then how many characters you want to indent. So here I'm indenting 2 for the different categories, subtotals, and then I'm indenting 3 for the overall total. And then here's our output. Okay, so that's the basics. So now we're going to talk, I keep saying the power of FML is the inter-row, row, column calculation. It's kind of like Excel, but not as easy. So in this case, I have a report that I'm doing sales by region across dates. And our goal is to calculate this quarter change column. So the quarter change is going to be the difference between the last month in the quarter compared to the last month of the previous quarter. So it's going to be 1997, the difference between that and September 1997. So how would we do that? We're going to create a report. We're going to sum some number of units across date. And I'm putting a compute because I want to add that extra column at the end where we're going to have the difference, the quarter change. So this compute is going to a value 0 because I'm just doing it as a placeholder. So think of it, if I don't have a column to put the calculation in, then I can't really do it. So you're creating that column. I'm doing it for a region. So Midwest, and I'm doing a tag as Midwest with a label of MW. And it's going to be over West, labeled W. And then I'm going to recap. Row 3 is going to be the sum of the 2. So it's going to be MW plus W. And I'm looking for only certain date ranges where date is greater than September 1st, 1997. All right. So if I run that, I'll get everything, and the last column now will be 0 because that's what my compute says. So to get that calculation, I'm going to use a recap. And I'm going to recap on line 10, recap MW column 5 equals MW column 4 minus MW column 1. So the MW in this case is the row, and then what's in parentheses is the column. So I'm going to have Midwest, West, the line 13 is going to recap West, which is going to be the West difference. And then finally, I'm going to do a recap to get the total. Now, because I don't have column references, it's going to do it for all columns. So in this case, the MW plus W column 1 is going to get added, in column 2 they're going to get added, and in column 3 they're going to get added. So if you want it only for one column, you need a reference. If you're going to do it across the board on all columns, there is no reference. Okay, let's run that. And now I get my quarter change. Instead of being 0, I actually have the value, which should be for the first one, 44,813 minus 46,84. And again, this is very simple stuff. You can do full budgeting where you have 1 month and then you have an ending balance at the end of the first column, and then you can carry that ending balance over to the first column, the first row of the second column, and then start your next month's budget values that way. That there's a whole lot of flexibility that you have within the FML product. Again, I showed you the screens from App Studio, and we are looking at having this incorporated in Designer. That's on the list. We also have Beyond Basics, where I talk about post and pickup. And one that I probably will do later is hierarchical reporting. So if you have a relationship between one field and another, a parent-child type of relationship, then you can easily say, show me this value and all of its children without having to drag and drop each child value, which is kind of powerful. So that's all I had. Remember, I said, please fill out your evaluations. There are special questions. I want to know what things you want in the product. So please do that. Again, I'll put it in the chat if you want to do it, look at the survey sooner, but we really appreciate it. And unless there's any other questions, that's it for me. Do we have any questions? I don't see anything in chat. Do you see anything in Q&A, Marcus? Oh, there's something here. Here we go. Can you create those same sample reports in App Studio? Yes. So Brad, the first one I did was in App Studio, and I just kind of built upon it. I didn't do the recaps and everything all directly in App Studio, but the initial drag and dropping. But yes, you can do all of this in App Studio. All right, is there any update on old focal point forum? Still site is down. So the focal point has moved to the community. And if you're not a member of community, I suggest that you join. There is a focus session in there. There's a WebFOCUS session. Shay, are you available that you want to might say something?
Yes. Hi, guys. Yes, as Walter mentioned, the focal point is being moved over to community. We will make an announcement in the next, hopefully by mid next week, and letting you guys know how to access that. But if you already are in the community, you possibly could see it in the article section. But let me find out if we have that live or not. And if not, then there will be an announcement going out very soon.
And I'd also like to say that we just launched our training area. I see you unmuted, Shay. You want to say something?
Yes, as Walter mentioned too, we have launched the new IBI Education Center. We just did a webinar on it this week on how you guys can get access if you are not in there. So if you would like more information on the Education Center or how you get access to it, shoot me a note or message me here in the chat, and I can send you the recording and the slides that we covered this week. But yeah, we have a lot of training out there available now. We will be adding new training every quarter. So we'll be constantly adding new courses, and we also are taking your suggestions if there's content you want to see that we don't currently have. So that's my shameless plug. Thank you.
And going back to community, I'm a member, but I'm not as active as I probably should be. So if you want to send me notes or something, or you have questions, and if it's something you think is simple that doesn't need a case, feel free to ask. If it's something that needs a case, I will let you know. This probably needs a case. But I'm trying to get more active in the community. So hopefully I'll see you out there. In FML, should there be always finite sort values? What if there are infinite values? Well, infinite is quite a bit. So in FML, if you're doing what I just showed you, yes, there are finite values. But when you start looking at the FML hierarchy, where I know this parent is related to these children, or I can create a parent-child relationship, then you don't need to know the actual values. So if a new child gets added into the picture, when you run your report, it will automatically get picked up. So it sounds like the FML hierarchy is something that you might be interested in. I'll try to get that out later this week. And in fact, Shay's been on me to get the next session topics. So I'll see what I can do. In the meantime, all of our previous sessions are recorded and available. A lot of them are available on YouTube. So if you might want to look on there and see if there's a previous FML hierarchy section or session out there. If not, we have old recordings because I know I've done this at least once before. Good question. All right, anything else? All right, so Marcus, I will let you take us into the scary world of DSML.
Thank you, Walter. Let me see if I can get the sharing right. First, start sharing the entire screen, share. And I suppose you see my screen, right? Walter?
Now, Marcus, can you just check your microphone setting because you're a little quiet there.
Let me see how to do that. 1 second. Is this better? I hear you louder, but you probably don't hear me louder.
That's just your speaker though, isn't it? Or is that your microphone?
Yeah. So you can't hear me at all?
No, I can hear you. So what you just said was better.
Okay. So I try to speak louder then. All right. So what I would like to do is to first give you a gentle introduction to machine learning with tabular data, the kind of data that FOCUS users are, of course, most familiar with. Then I will describe the type of problems that you can address with this kind of machine learning. And next, I will demonstrate how you can train and use machine learning models in WebFOCUS with your own data. This functionality to train models and to do inference has been built right into the heart of the reporting server. It is driven by calls to a suite of compute functions from within table requests. This, of course, does not mean that we want you to write your own FOCUS for machine learning. Instead, as you will see, our machine learning UI will generate these FOCUS for you, execute them to train and run models, and display results in various ways. The fact that we have built in this functionality right inside table means that it really capitalizes on FOCUS capability to retrieve data. But also it means that when you make predictions with a model, they end up in your table requests, and you can further process them in all the ways that FOCUS is good at. And often with machine learning predictions, you want to screen them to look for certain kinds of things. So let me first give you a brief introduction about machine learning with tabular data. So suppose you have a table, with columns X and Y. And often there's one column of particular interest, call it the column Y, the target Y. And it would make sense, it would be nice if you could explain the values in the target column Y in terms of the values of the other columns. For instance, the target column could be something like this loan has defaulted or this employee has left. And you would like to understand those values in terms of values of the other columns. That is, you want to find a function that maps the values in these other columns called predictors onto the target value. That really means you want to find regularities and patterns in the data. So this function f, y is function f of x, is called a model.
Marcus,
And yeah,
are you supposed to be sharing?
yes, I am supposed to be sharing. Okay, there we go. Let me go back to the sharing. Home. It has completely disappeared. Hold on. I share again. Entire screen, share. Am I sharing now?
Not yet.
That is bizarre.
So you have to click on the share and then.
Yes, I do. I click.
Oh, you
on
should be
share,
sharing. So why?
And I click on entire screen, and then on the button down, share. And then, oh, other people saying they were seeing the presentation. So
Oh, that's
I'm not
weird.
quite sure what's going on here.
All right, well, go do what you were doing then, and well, I'll get confirmation because strangely, I'm not seeing it. Oh wait, I see it now. There we go.
You do?
I got it. It was me.
Okay, so let me briefly start this page again. You have tabular data. There may be one column of particular interest in these tabular data, and you may want to understand the values in this column of interest in terms of the values of the other columns. This column of interest could be something, if the rows describe employees, the column of interest could describe whether this employee has left the company, or if the rows denote loan applications, the column of interest could tell you whether whether this loan was defaulted on, etc. So if you want, you basically want to find a function that maps the other columns onto the column of interest, and this function is called a model. And models can be of various mathematical types, like you have functions can be of various mathematical types. The pre-calculus function y equals cosine x, but functions can also be described by decision trees or collections of decision trees or neural networks. And correspondingly, there are many different algorithms of trying to detect patterns in the data that explain the values of the target column in terms of the values in the other columns. And the process of finding the form of this function f is called training. It's an iterative process where you try to fit to the data. Once you have this function f and you get new data, you could input the predictor values of the new data into the function f, and it would give, and the model would tell you, for instance, if this loan has a high risk of being defaulted on, or whether this employee is likely to leave, or something like that. Now, the target column can be of various types. It can be, it can have more or less continuous values. Say the target column is the price at which a home is expected to be sold. Then we talk about a regression problem. The target column can be binary, like fraudulent transaction or not fraudulent, or employee left or employee stayed. Then we talk about the binary classification problem. And the target column can have multiple discrete values that cannot be ordered. Types of diseases, for instance, all the columns could describe medical observations, and they could correspond to one or to a few diseases. These tasks, these problems are called supervised learning because you can identify a target column and you want to explain the values of the target column in terms of values in the other columns. There's also unsupervised machine learning problems where the function f that you create do not explain the values of one column in the data, but return other things like outlier scores, which tell you how unusual the particular row is, or maybe clustering scores, which try to tell you that the data is clustered in groups of rows that are alike within clusters and very different across clusters. I will talk about two supervised machine learning problems here, a regression problem and a binary classification problem. So these focus functions that I was talking about, these compute functions, they reflect the different tasks. Here's a list of them. We have functions for regression, for binary classification, for multi-class classification. And the different functions reflect the different types of algorithms and the different types of models you would create. And so the first example I would like to look at is employee attrition. So suppose you have a data set in which each row is an employee, and the columns record demographic information about the employees and job-related information about the employees. And suppose you have recorded all this information at some time, then say 12 months later, you record for each employee whether they have stayed with the company or left the company, and you populate the attrition column with only two values, stayed or left. So we call this data historic data, right? The data about the employees was collected at some time, and say 12 months later, we populate the attrition column. If you were able to understand the values in the attrition column in terms of the values of the other columns, if you have a model that can produce the values of the attrition column, then you would have the power to record information about employees and predict whether they, within 12 months, would leave the company. And that, of course, would be a very useful thing to be able to do. These binary classification models, they would predict the value of the target, y, which in our case is stayed or left. But actually, it is, for binary classification problems, more useful not to predict directly the value of attrition, stayed or left, but to predict or to output the probability that the value for attrition would be left, meaning the probability that an employee leaves within 12 months of recording the information. In many settings, that also much better quantifies the output. For instance, if you want to evaluate the risk of a loan application, you really want a number between 0 and 1 that tells you how risky the loan is. For this to work, first, of course, you identify the target column in the data, that is attrition, but then you identify the positive class, the value in the target column you're really interested in at detecting. Here, that is the value left, the employee has left. And our models, our binary classifiers are now going to predict the probability that an employee has left. You can, of course, convert the probability that an employee has left into a clear assignment, left or stayed, by using a decision threshold. You would say that if the probability that the employee has left is greater than some threshold, we predict the employee will leave, otherwise the employee will stay. What the value is of this decision threshold, it's another matter. I will talk about that a little later. It doesn't necessarily have to be 0.5. So let's go to a demo and see how this works.
Marcus?
Yeah.
There's a question.
Oh, yeah.
Are the functions fully built into the reporting server, or do they require a DSML to be installed or configured?
That's a good question. I will talk about that at the end. You will need to install something and activate it, but I will tell you that at the end. Yeah, does that answer the question? So here I have gone to the reporting server, and I'm going to start a data flow with some information, with some data set here. The data set I loaded here into the data flow is exactly this data set. Each row corresponds to an employee. We record information about the employee, demographic information, but a lot of job-related information. You see there is numeric and non-numeric data. And the last column in this data set tells you whether this particular employee was still with the company 12 months after recording the information or not. And we want to understand the values in that column in terms of the values in the other columns. And that is a binary classification problem. In order to do this, we click on the left on the train models icon, and then we click on the binary classification icon. This adds another pill to the data flow and opens up a panel. In the panel, it asks you to identify the target column. It made a drop-down list of all binary columns in the data set. In our case, it is the attrition column that we are interested in. And the positive class, we have the choice between left and state, but we are interested in predicting the value attrition equals left. I will not talk about this here, but here we have the set of predictors. Those are all the columns which we want as input for the model. Now, generally, you would not think that employee ID is a useful predictor. Yeah, so we remove it. And you can remove more columns, but sometimes you would remove gender for political correctness. But we leave it in. So we take all the columns in the data set except for the index column, basically, as our predictors, and we click on apply. Now, we see that there are 5 different algorithms that in principle we have available: logistic regression, k-nearest neighbors, random forest, XGBoost, and neural networks. So if we select these 5 choices, we will end up with 5 models: a neural network, an XGBoost model, random forest, and we will compare their skills, and we would generally pick the best model. For running time purposes, I will just do 2 models now, which means we're going to make a logistic regression model and an XGBoost or gradient booster. All we now have to do is we have set up the problem. All we now have to do is click on this button and wait a little while. This will take about half a minute. But while we are waiting, I'm going to tell you something. I'm going back to the PowerPoint and tell you some more about what we are going to see in a minute. I go back to... Now, what happens during this training? One thing is our models are, in fact, pipeline models. This means that the non-numeric data which you saw in the data set, the non-numeric predictors have to be converted into numeric data somehow, because all machine learning algorithms only work with numeric data. If there is missing data, they have to be dealt with in some way. We impute missing data, or we can delete missing data, and things like that. Secondly, looking for patterns in the data, finding this function f of x has to be done in a statistically responsible way. That means that the challenge really is is not to overfit on accidental patterns that your training data may have, but on the other hand, also not to underfit to miss relevant patterns. You really have to strike a balance here. And that is usual in statistics. Statistics is often concerned about making statements about large populations of data from studying a sample. And you have to be very careful that you don't pick up signals from the sample that are not existent in the large population. Some optimization is needed to strike this balance. And this is a process called hyperparameter optimization, which we automated, and which basically means that many models will be trained under the cover and then compared. At the end, we will also evaluate the model's skills very comprehensively. We produce an evaluation report, which you will see in a minute. But in order to understand this evaluation report, I have to explain two things. One is when we use data for training a model, we don't really train it on all the data. We train it only on 80% of the data. And once the model has been trained on these 80% of the data, we will test how well the model performs on the remaining 20% of the data. We can do that because, of course, we have the values of the target column in these remaining 20%. And all we have to do is compare the model predictions for this test set with the actual values of the target column. Since our model produces probabilities, we convert them into real class assignments, but then we compare the class assignments with the values in the target column. There are only 4 possibilities here. Either the target column says that an employee has left, and we as predicted the employee has left. That would be a true positive, or the value in the target column says the employee has stayed and we predicted he has stayed. That would be a true negative. But it also happens that we predict that the employee has left while the target column says no, he has stayed. That would be a false positive, and conversely, you have false negatives. You can collect this information about the training data in a confusion matrix, and here you have such a confusion matrix. And of course, the ideal situation would be if the off-diagonal elements, the false negatives and the false positives, were 0. The training set we just used had 5,000 rows. And so 20% of these 5,000 is 1,000 rows. And here you see the result of the predictions of all these 1,000 rows. Now, from the confusion matrix, some performance metrics are derived.
Marcus?
Yes.
As another question, in the
Yes.
is machine language learning limited to 9.3, or is it available in an earlier release?
It is available in earlier release, but I would say the progress we have made is so large that I would hesitate. And yes, it is available, but I would say a 9.3, in my opinion, is the first mature version of it. 9.3.4, I would say, yeah. And yeah, that's my opinion about this. But okay, so we have this confusion matrix, which we produce with the test set that was 20% that of the data that we set aside. From the confusion matrix, we compute some performance scores. And the easiest one would be to say, well, you know, we just look at the fraction of incorrect scores, the off-diagonal element, incorrect predictions, and use that as a score. That is called accuracy, the number of correct predictions divided by the number of all predictions. But there is a little bit of a problem with it, because in many problems of this type, you have only, say, like 1% of positive instances. Suppose you're hunting for some disease. cancer or not cancer, and 1% of your data has the cancer, you could make a trivial classifier which says nobody has cancer, and you would have a 99% accuracy, but have a useless model. So accuracy often is not the greatest performance score. Instead, precision and recall are much more useful. Precision really only focuses on the right column here. It is basically the fraction of positive predictions that actually are positive. And recall only focuses on the bottom row. That is the fraction of actual positive instances that you have detected to be positive. There is a compromise between precision and recall that is called the F1 score, which is a very popular score to use. The thing is with binary classifiers that they output a probability. You have to apply a threshold to make a positive or negative prediction. And there is a trade-off. If you make the threshold rather large, close to 1, you will always have very few false positives, but very many false negatives. And conversely, if your decision threshold is low, you will squeeze out the false negatives at the expense of having more false positives. In terms of these scores, that means that there is a trade-off between precision and recall. And again, some sort of optimization could be done. And our models, as you will see in a minute, suggest a decision threshold that optimizes the F1 score. So now we go back to the training. And the training has been done. And remember, we attempted to train 2 models, a logistic regression model and an XGBoost model. We've done that. And we have 2 scores here. I will not go into details about these scores. The maximum score is 1. We see that the logistic regression is slightly better than the XGBoost. You would naively now pick the logistic regression as your model, but let's inspect these models a little bit in more detail. So we close this panel here, and we get a whole evaluation report. Number 1 is for our logistic regression. If we look at the right graph, the recall is plotted against the precision as a function of the decision threshold. This is what I said before. You see a trade-off between precision and recall. If your decision threshold is low, that favors recall. The recall will be high here, close to 1. And if the decision threshold is high, it favors precision. And you could try to find what you think is your optimal decision threshold here. The best point would be the point where both recall and precision are 1, and the best classifier would be 1 where this orange curve comes very close to 1. But given this classifier that we trained, you could use this slider here to change your decision threshold and see what the precision and the recall would be. The receiver operating curve is the curve on the left, is another popular curve that is often used. Again, it's defined in terms of false positives and false negatives. The false positive rate obviously should be as small as possible, and the true positive rate should be as high as possible. The optimal point in such graphs is somewhere here, and the best models have, this orange curve coming close to this point. If you would have a classifier that would make random predictions, outputting randomly a probability between 0 and 1, the precision recall curve would be this one. And every deviation of the orange curve from this dashed line indicates that this classifier indeed has some skills. Here in this next tab, we see these 4 scores I talked about: accuracy, precision, recall, and F1 score. And let me and do this. And so you see 4 bars here with these 4 scores. We have calculated these scores by using the decision threshold that makes the F1 score as large as possible. The graphs here tell you how the 4 scores differ with the setting of the threshold. And you see that the red curve is the F1 score. And you see that we have chosen a threshold here that sits at the maximum of the F1 score, but you could use a different threshold. The corresponding confusion matrix is this one here. And you can read off your true negatives, etc. here. Now, if you had reason to say, for instance, I want as many false positives as false negatives, maybe because the cost for your particular problem of a false negative and a false positive is equal, you could try to look for a different threshold. And but you can set your threshold however you want it. In the left graph, in gray, you see the scores calculated with our F1 optimal threshold, but you see how the scores change if you change a different threshold. For instance, if you change a very high threshold, which favors precision, you see the precision going up, but the price that you pay is that the recall goes down, and generally also the accuracy and the F1 score go down. Feature importance, this is something else. It gives you some insight. What are the most important, the most influential predictors, columns for this particular model on aggregate? And job level, marital status, remote work seem to weigh very heavily for this model, and that's useful to know to see what your model is really looking at. We also deliver a learning curve. A learning curve tells you basically how much data you need to train a model. What we did here is we trained the model on all our data, or here on 90% of the data, 70%, 50%, etc. And you see the performance metric go up. If this curve keeps going up here, it would be worthwhile collecting more data, because you would probably be able to train a better model. But if the curve flattens early on, you know that you have enough data. Now, you can save this model. Before I do this, let's go to Diagnostics, View Source. And here you see the underlying code that has been run to train the model. And here you see a FOCExec that we have automatically generated. But in this FOCExec, you see a compute function. You see the function classify BLR, that stands for classify binary logistic regression. And it has a lot of input parameters, among which all the predictors you chose, and some more parameters that you can actually control in the UI. But I will skip that. We can save this model. So let's save it. Yeah, we just save the model, some clicks, and we have the model saved. The other information here, remember when we just chose these 2 algorithms, we could have clicked here and the whole panel opens up with so-called hyperparameters. And if you're a bit more advanced, you could play with it, but in order to maybe find even better models. But generally our defaults work very well. So now we have saved this model and see what you would use it for. So suppose you have, one second, suppose you have data with some new employees. Let's take these data. We have data here with 4 new employees. And you see the same information recorded for these 4 employees. But what you don't see, and what there is not, is this attrition column. We just want to use a model to predict whether these employees will leave or stay within 12 months. In order to do that, we click on Run Models. And what shows up here is the model we just trained. That is a model that's applicable to this data. We click on it. We click on it. And it shows up as a compute in this table. We can click on here. And what we find here now is all the data in this table, including the compute, which is the model has been run to produce both the probability of the employee leaving and a class assignment. Unfortunately, I saved the model after I was playing with the decision threshold, so please ignore this. It says all stayed. But let's have a little look here. So for this first employee, this 38-year-old male, the model predicts that's a fairly good chance that he would leave. Now, making predictions is one thing, but you know that these days machine learning models are more and more used for making predictions that directly affect humans. And it would not only be nice, but it's actually often illegal not to provide supporting information why the model came to this particular assessment of this employee. In order to get some insight why this model for this particular employee came to this conclusion that he's quite likely to leave, we just click on this prediction and a panel opens up. And this is our explainability panel, which says that for this particular employee, the marital status, remote work, and work-life balance were the 3 most important factors in having this high probability of leaving. This plot shows that this is a bar plot where the bars can show to the right or the left. When the bar points to the right, it has increased the probability of leaving. So that means these are factors here that increase the probability of leaving. This employee had a very high number of promotions, which has sort of reduced again the probability of this employee to leave, which sort of makes sense. But so let's have a little look at it. So this is a single person who is not allowed to work remotely, and his work-life balance was poor. So one thing is knowing that this contributes to this employee likely to leave. Another thing is ask yourself, what can we do to keep him? Well, this is in this case very simple. If we just allow this employee to work remotely, which probably also would change his work balance, at least from poor to, let's say, fair, and we recompute what the model would assess now, you see, bingo, this employee would have a much, much lower chance to leave. So in terms of, for instance, let's say loan applications, if you're being denied a loan, the natural question to ask is why? Yeah, and what can I do to get a more favorable model outcome? And this is the sort of thing you can do to do that. So now I go back to the PowerPoint. I will briefly show you one other example where already I trained the model. This is about the FIFA ranking of soccer players or football players. So we have a data set, which we'll see in a minute, with 42 or so specific skills of football players and a FIFA ranking for each of these football players. And what we are interested in is, can we, based on the skills of a particular football player, predict the FIFA ranking? And So we train a regression problem. The FIFA ranking here is a number going, I think, from 30 to 100 or something, which is a regression problem. And we set up the problem the same way as the binary classification problem. We load the data set, we get the data set into the flow, we click on regression problems, we choose the target, we choose the predictors. And after the training has been done, we get, for these 5 different algorithms, 5 regression comparison plots. What these show here is, again, on the tests data where we know the football player's ranking, we compare the actual ranking of the football player with the ranking predicted by the model. The red line would be the predictions of a hypothetical model with perfect predictions, right, where the predicted ranking equals the actual ranking. That generally doesn't happen. There's some scatter around that line, and the measure of the scatter is measured by the root mean squared error. And obviously, the model with the smallest root mean squared error would be the most accurate model, which in this case is the neural network. But there is more here. You can also see that, for instance, the k nearest neighbors algorithm has some sort of systematic error. It has the tendency of overestimating low rankings and underestimating high rankings. Random forests have that tendency also up to a point. This is important information to have about the models. But let us go to WebFOCUS and see what we can do. Excuse me.
Marcus.
Yeah.
So the question is, can you automate the training of models? Say you train and save a model, but you'd like to retrain it weekly on new data and always save the one with the best F1 score. Is that possible?
That is such a good question. Yeah, in principle, yes, it is possible by saving a data flow, right? So that answer would be a yes. But it opens an entire can of worms, right? Because we also know that, for instance, especially in financial settings, models go stale, meaning that you have detected patterns in the data and you encode these patterns in a model and you apply the model. This is, of course, the ability to do so depends very much on these patterns remaining relevant, right? And generally, patterns gradually drift, and you would like to retrain your models with fresh data every now and then. And although in general one doesn't make forward-looking statements, of course, the detection of drift in the data is something that we will provide at some point. But saving data flows, yes, that would be the way to do that. Let me go back to my my football players here. So I have trained these models, and you saw the results of these models. And the best model was the neural network, and I saved it. So now suppose I get some new football players that were not part of the training data. Let's have a look at these football players. And we see a couple of football players, Ronaldo and Van Dijk and Buffon. And for those who know something about football, these are very different football players. There's an attacker, there's a goalkeeper, there's a defender. And remember, our model to predict the ranking did that based on the skills of the soccer players. And it can be expected that these soccer players have very different skills. So let's run the model to predict the skills of these players. So this was our model. We attach it again as a compute into this table, and we run it. And now we get predictions. So we see that this guy, Cristiano Ronaldo, gets a high prediction of 93. this top group all gets very high rankings. The other group gets lower rankings. So let's see if this makes sense to us. Again, we do the explainability thing. We click on the prediction of the model. The explainability panel opens up, should open up. And so this is Cristiano Ronaldo. The top factors for getting a high score was his superior finishing capabilities. It says the very high value of finishing increases the model outcome by a certain amount. Positioning, ball control, shot power, etc. These are very much skills of attackers, and he apparently is a very good one. That is why he got such a good score. We can look at another player, Buffon. He is a goalkeeper. We want an explanation for his score. And we see that the model has identified goalkeeper handling, goalkeeper position, goalkeeper diving as, and all of them are very high as contributing factors, or the major contributing factors for him having such a high score. We can do one more. Van Dijk, he is a defender, and you see that the model indeed has figured out that typical defender skills are very good, like marking and interceptions and tackles. Let me go back to the PowerPoint. Some technical remarks. This machine learning functionality, somebody asked that, is actually implemented in Python. It's not really Python. We're using some Python ecosystem for machine learning. It only looks like Python, really. Behind the scenes, it is a lot of very highly optimized C++ for numeric computation, but it is Python. And Python is not part of our reporting server. The reporting server is written in C, C++. So the way we engineered this is that the reporting server calls a Python service, transfers the data to the Python service, and gets the results back from the Python service. And that requires some installation of this Python microservice. So from the eDelivery side, there is what is called binaries that need to be installed. A Python server is installed. Now, the thing is, this Python server needs to be installed either on a Windows machine or on a Linux machine. So regardless of the reporting server platform you're on, that is where you install your machine learning services. You can start them up, and you can activate access to them in the reporting server by simply adding one-liners to configuration files, adaserv.cfg and ada-sprof, and during the installation, these URLs are actually given to you. So yes, you have to install it, and once you install it, these icons for the machine learning services end up in your reporting server. So in conclusion, you have learned something about, oh, that's a typo, machine learning capabilities in WebFOCUS reporting server. You've learned that it's an integral part of the reporting server. And a really good thing is that your data will actually never have to leave your premises. You can do all this without sending your data to some cloud service. And that would conclude this presentation.
Thanks, Marcus. Are there any other questions? Okay. So I'm putting the link for the survey again into the chat. Please, please, please fill it out, answer the special questions. What are you looking for in the product? We're about to jump into the mainframe part of the session. So if you're not a mainframe customer, feel free to drop off. Have a great weekend and month, and we'll see you next month, hopefully. Marcus, I think you're still sharing. I don't know if you want to stop.
Yes,
there you go. All right, we're in the middle of a cloud conversion. Can this machine learning be utilized with cloud saved data?
Well, it can be utilized with all data that you can retrieve within in the reporting server.
Alrighty. All right, I think that's it for the questions. Mr. Blood says, thanks, Marcus, great job.
Thank you, Walter.
All right, let me get my screen shared. There. Okay, so I'm going to talk about calling REXX functions from within FOCUS, focus on the mainframe. This technique can also be used with WebFOCUS that you're running on the mainframe. So what is REXX? So this is just a brief overview of what REXX is. Basically, consider it a scripting language. It's an extension of clists. And when would you use those? Well, here, if you're running FOCUS and TSO, we have a lot of clists that will then allocate the files that are needed for the FOCUS session, and then call FOCUS and start FOCUS. The REXX will do exactly the same thing. So with that in mind, here's an example clist where I have my allocation for errors, FOCUS master, and I'm doing this new DD called fuzzREXX, which is going to point to my library, my data set that contains my REXX subroutines that I'm going to call. And then I call the FOCUS module in order to invoke the FOCUS product. And if I were to convert this to REXX, it would look like this. So the commands were similar, but the syntax is a little different. Notice these are in double quotes. Comments are /* and then your comment, and then you have to end with a //. So if you go over multiple lines, then you only need the /* at the beginning and the // at the end. For a REXX, you have to have the first line as a comment that has the word REXX in it. All right, so what is a REXX function? So a REXX function is you have code, REXX does something, and you get a return value. Do you have to have a return value? No. The REXX can do some system things like allocate files, create, read databases. There's a whole bunch of things that you can do with REXX. In this case, I have this REXX called getJName, get your job name. So it's going to do notice the comments are grayed out. And the one that says say Jez JBNM, I have the /* on the line before and the // on the line after. But everything in between is a comment. So the say is basically a print, the write is going to show you on the screen in your output. We just have a comment. Started, getJName fuzzREXX. You have trace options, and I'm not going to go into all of the REXX coding options. But the trace end basically says no tracing. Parse upper says whatever parameter I'm getting, I want to separate it into two parameters. When we get to how do you call this function from FOCUS, you're going to see where this P1, P2 are coming into play. The job name is going to be retrieved using an MVS function called MVSVAR. And the result of that is going to be the job name where this function was called. So if you're running in batch and you want to know what job you're running currently, you can then call this REXX function and it'll tell you the job name that was called. We're going to see it the next function, which is going to get the actual job number. Then we're going to say finished, and then we're going to return. Notice nothing in here tells me what the value of the job name is. The return JES, JB, and M is the link to transfer between your REXX value into your focus value. Okay, this one is the get JNum. This is your job number. It's very similar, except it's doing some other functions. Some of the information is stored in hex and binary. So the C to D and all that will do some conversion, like convert to decimal. So I found this because actually this was from a customer case. They had this code and they incorporated the job name and job number. I believe it was some sort of job tracking system that they had. All right, so when you want to call the function from focus, if you're not returning any data, there's no data transfer, you're just calling a function and it's going to do something. It's going to set your environment. It's going to read a file, determine if you're in test or prod, allocate files accordingly, those kind of things. You can just call it using a TSO call. So you get your TSO call, your library, in this case the fuzzREXX, and then the REXX name you're calling, and then your parameter list. If you are returning a value, which most functions do, then we're going to call it just like any other function in focus. So in order to call a function, you have to have fuzzREXX DD allocated to your library that has your REXX function in it. There is a setting set fuzzREXX equals on, which you have to have turned on, and it's on by default. So if you don't turn it on or forget to, no problem. And then we have our dash set, and we're going to have our dialog manager variable name equals your REXX function name, and we have an in length in parm, and you could have several, and then we have an out length and an out parm. So this is considered the old legacy type of function call, as opposed to the simplified. The simplified functions, we removed any of the length parameters that you need. But because this is something you're writing, we need to know how many characters are you passing in, and then how many characters are you expecting to return. Out parm should be just the format. So in this case, if I'm expecting 8 characters back, the out length should be 8, and the output parm should be tick, 8 tick. So in our REXX that I showed before, I mentioned we did have the fuzzREXX allocated. And in my FOCUS, I'm going to do a set amper job name equals get JName. And I'm setting it as 8 because I'm returning an 8-character job name. Notice there's only one parameter, and that one parameter is an output variable. I'm going to then type it in my FOCUS code. Then I'm going to call to get the job ID. Again, it's also 8 characters. Display that, and then that's basically it. So when I run it, this is my output. Started, finished, those came from the REXX code, from the say commands. Job ID is coming from the dash type from within focus, and I ran this in my TSO session, which has my ID. And then I have started and finished for the get the number, and then my job ID number, again, is coming from the dash type from the focus code. So that's basically it. Again, please fill out the evaluations. Yeah, so please fill out the evaluations. You guys here are my mainframe people, so anything on the mainframe focus side specifically that you're looking for, or if you aren't running PDS server on the mainframe, you know, we want to know. I can't emphasize that enough. All right, if there's any questions, let's see. I'm not seeing anything. So I guess I'm done. All right, thanks everyone for showing up and taking your time to join us and learn about different features of the product, and especially the DSML. Marcus, thank you for joining us. You're muted.
Thank you, Walter.
And we'll look forward to seeing everybody next time.